Hi there. I'm going to tell you a little bit about the pH portion of Lab 3. And the objective of this part of the lab is to first make a total of 3 different sucrose solutions using the parallel dilution method. 2 of these sucrose solutions that you make will have added ingredients in them to create a buffer, and that buffer is meant to withstand any changes, acidic or basic, happening to that solution. And then to those 3 sucrose solutions, you'll divide them, and with the help of a pH meter, measure the pH of the solution every time you add a little bit of a strong acid, hydrochloric acid, or a strong base, which will be sodium hydroxide. So first, let's talk about the making of these 3 sucrose solutions. So in the pre-lab for Lab 3, you should have been given some information that's required to do parallel dilutions to make all 3 of these solutions. So you should have done those calculations beforehand, and you should have filled in these blanks in the lab procedures with your calculated values. And it's these values that literally will be the recipes you will follow to make all 3 sucrose solutions. And you're going to base your measurements upon these numbers that you calculate. So the numbers that you calculate should help you figure out which would be the best measuring devices to choose. And like you've encountered in Lab 1, there are a variety of different volumetric devices in the lab, but you want to choose the ones that will measure these amounts the most accurately. So even though the total volume of all 3 of these solutions should be 100 milliliters, and eventually that means you'll have to put everything into a 100 milliliter graduated cylinder like this one, I wouldn't choose this cylinder to measure separately all the stock solutions that are required, because if you do the calculations, you'll realize that the amounts of each stock solution will be well below 50% of this cylinder's capacity, which means using this cylinder wouldn't be the best, most accurate measuring device. All right, so I've already calculated beforehand all the amounts of each of the separate stock solutions that I'm going to need. I've also calculated by subtracting from 100 the amount of distilled water that I'm going to need to make all 3 of these solutions. So all that's really left is to measure. And in the lab, the stock solutions will be presented to you in their own separate bottles. But because these are community stock solutions and you don't want to cross-contaminate them with each other, it's always a good practice to pour out a little bit more, maybe just a little bit more, of what you'll need of each stock solution into a smaller container. Don't do any accurate measuring when doing this. And then bring this smaller container of stock solution back to your lab table and do your more exact measuring when you get to your lab table. And again, to avoid cross-contaminating these stock solutions with each other, not only am I putting a little bit of them into separate vessels, but I'm also going to use separate measuring devices for each of them. And I know there's going to be a lot of glassware, but again, it's to avoid cross-contaminating these very limited stock solutions with each other. All right, so let's say that I have properly first calculated all the right amounts in milliliters of everything that I'm going to need. I've divvied up all of these stock solutions into separate vessels, and then I've done my more accurate measuring of these stock solutions in the appropriate containers like this one. So for the first sucrose solution, I calculated that I'll need 20 milliliters of sucrose, and hopefully you agree with me based upon your calculation in the pre-lab. So I would choose maybe this, a 25 milliliter graduated cylinder, or maybe even, if you really have to, a 50 milliliter graduated cylinder, but that may not be the best choice of all, to measure that 20 milliliters, because 20 milliliters is at least half of this cylinder's capacity. And I'm going to pour that sucrose stock solution into this. My eventual total volume is 100 milliliters, and the stock solution is 20 milliliters of that, so I'm going to pour that in here. And to bring it up to the correct final volume, you can do it one of 2 different ways. One way to measure the water that's required, and I'm going to need a total of 80 milliliters of distilled water, because 20 plus 80 equals 100 altogether. You can either measure the water separately, which would require using a separate device in order to measure it, or to save you one piece of glassware, you could also just pour the water into your graduated cylinder, like so. and you're aiming for the 100 milliliter mark on this graduated cylinder, and I'm stopping a little bit short of that 100 milliliter mark so that I don't go over, because you can't take any water away if you put too much, but you can always add extra if you're a little bit short. So to get myself, because I have shaky and caffeinated hands, to get myself all the way to that 100 milliliter mark, I'm going to use one of these transfer pipettes to grab a little bit of extra water. I'm going to add that water, paying attention to the meniscus, add that water all the way up until the bottom of the meniscus, which if you recall looks like a smile. Bottom of the meniscus should sit right on top of that 100 milliliter line, and I'll show you that shortly once I get it there. So that is my graduated cylinder topped off with distilled water all the way up to the 100 milliliter mark. And that's my first solution, which just contains sucrose and water, so it doesn't have any extra ingredients that'll create the buffer part of the solution. And to mix the contents of this solution, I would stretch over a piece of parafilm, make sure the seal is tight all the way around, and then holding that parafilm seal with my gloved hands, invert this graduated cylinder, not shake it, once or twice. So before we begin with the actual pH readings, it's really important to calibrate the pH meter that you're going to be using. And this is basically a one-time calibration that'll tell the meter to read a certain pH a certain way. It's sort of like tearing or zeroing your balance before you get started with it. So we're going to do a one-time calibration with this meter, and the measuring part of the meter, so you may have encountered this LabQuest display before. You used it with a spectrometer as part of Lab 2. So you're going to use this display again, but instead of being attached to a spectrometer, now it's attached to this, which is the measuring part of your pH meter. It's called an electrode, and the electrode, the measuring part of it, is really the bottom part of it. That should stay wet at all times, which is why it's being held in a special pH 7 buffer before we begin. And it's while it's sitting in that buffer that you're going to do the calibration. So the calibration procedure is basically going to tell the meter this buffer is a pH of 7. That's tearing your balance, if you will, and then you're ready to get started taking measurements with it. So in your lab procedures, in part 2 of your lab procedures, there's a series of steps, and you shouldn't skip any of these steps. Follow them one by one. They will tell you what to tap on this display and in what order to get the calibration done. And again, since we are calibrating this electrode while it's sitting in a pH 7 buffer, the end result of the calibration is the display should read a pH of 7. And sometimes the digits might waver a little bit, but that's perfectly fine. So once you get that calibration done and the display, the LabQuest display, says a pH of 7, you are ready to begin the titration process. And the first thing you'll want to do before you titrate anything is to divide each of your sucrose solutions neatly in half. So 50 milliliters, which is half of 100, will go into one beaker, and the other half, or 50 milliliters of that solution, will end up in a second beaker. So you should end up with a total of 6 different beakers, each holding a half of a particular sucrose solution. I have my pH meter already calibrated, so the display reads a pH of 7. And if you recall, pH is just a number and it doesn't have a unit. So you're going to be paying attention to, when you take your pH readings, you're going to be paying attention to that number that's in the red box. I am almost done dividing up all of my solutions in half, and you're trying to do it as accurately as possible. So each of these beakers contains 50 milliliters of one of the sucrose solutions. I didn't use the beaker to measure that 50 milliliters. What I did was something like this, where I poured out 50 milliliters of the graduated cylinder into one beaker, and here's the other half, the last 50 milliliters. Just gonna pour that neatly into the second beaker, since the graduated cylinder is probably the most accurate measuring device that's here. All right, so now that I've divided up all 3 of my sucrose solutions, Now I'm ready to begin titrating maybe the first one, which would be one of these halves of the unbuffered sucrose solution. And that it's unbuffered, if I were to add a strong acid like HCl or a strong base like sodium hydroxide to it, it should change the pH pretty quickly to either an acidic one or a basic one. Now, in order to do the titration, you'll want to take one of these halves of the sucrose solution that you want to titrate, and you want to put it onto the surface of this stirrer hot plate, and you've used this before to stir solutions in previous labs, so that's what we're going to use it for now. So we want to get this solution stirring, and like before, you may have used one of these magnetic stir bars. I'll use a small one, and you kind of want to center it for now in the middle of the stirrer hot plate. And I'm going to use the dial on the right side of this stirrer hot plate to control the stirring action. And I'm just going to turn it up enough so it's stirring pretty constantly, but it's not a huge vortex that's going on. The next thing I want to do is I want to move the electrode of the pH meter from its holding spot, this pH 7 buffer, and into that solution. And once I get it in there and situated properly, I'm going to wait about 10 seconds and then read the pH meter, and that'll tell me the starting pH of this solution even before I add hydrochloric acid or sodium hydroxide to it. So to prevent the electrode, once I get it in there, and the stir bar from hitting each other, I usually like to move the beaker a little bit so the stir bar is sort of squished to one side of the beaker. And then I'm going to take the electrode out of its holding buffer, and before I move it into the solution, I want to rinse it off with some fresh distilled water, which is what's in this squirt bottle. I'm going to hold it over a beaker that'll catch all of that rinse water, so I'm just going to douse it, kind of like giving it a little bit of a shower. And you want to be really thorough about doing this, because what you want to avoid is carrying over any of that pH 7 buffer, so don't be shy with adding the water. And I'm spraying the table at the same time, but that's okay. Once I've given the electrode a thorough shower and rinsing off, I'm going to move this over as carefully as possible so I don't knock everything down into this beaker, and it's going to stay in there the whole titration long, but I'm going to try to point it away from the stir bar and gently set it in and just let it sort of naturally lean back, and that's how it's going to remain. I'm going to count to about 10 starting now, and then I'm going to take a quick look at my LabQuest display, and it reads about 8.17. So that would be the first pH that I would record in my lab notebook. And that's with the addition of 0 milliliters of either hydrochloric acid or sodium hydroxide. And I'm going to titrate this first with hydrochloric acid. So my first column would be 0 milliliters of HCl added. Second column would be a pH of 8.17. What I'm going to do next to this solution is I'm going to titrate it with hydrochloric acid, and that's what's in this bottle right here. And this hydrochloric acid is at a molarity of about 0.4 molar. That's enough to irritate your skin at the very least, so that's part of the reason why I'm wearing gloves. And I'm going to be really careful with measuring this hydrochloric acid. I need to measure it 1 milliliter at a time. And what I'm aiming to do is, as I add a milliliter of HCl to this solution, I'll let it stir for a second. I'll read the pH meter after adding that HCl. I'm aiming for a pH with the hydrochloric acid being added of 3 or below. So if I reach a pH of 3, I can stop. If I haven't reached a pH of 3 on the display, I'll add another milliliter of HCl and keep on repeating that until I reach that pH of 3 or below. All right, so even if it's 3.01, you have to add 1 more milliliter of HCl to get it below a pH of 3. Now, what's going to allow me to measure 1 milliliter of HCl carefully, and also in a way that I'm not using the same device necessarily over and over and over again, is probably this micropipetter, the 1000 micropipetter, because 1000 microliters is equal to 1 milliliter. So I can set this guy to 1000 microliters. And you know from previous experience that micropipetter tips are usually one use only, so one tip to one measurement. So I'm going to dispose of each tip every step along the way. All right, so I'm going to open up this bottle of HCl, and again, this is a strong acid, so you want to be really careful about not getting this on yourself, on your table, or anything else. I'm going to apply a tip to this micropipetter that I've already set to 1,000 microliters, and then I'm going to take the lid off of this HCl bottle and just put the front part of the tip in there. I've already pressed down to the first stop on this micropipetter, and now I'm going to let go so that the plunger comes all the way back up. And you want to do this carefully so you're not splashing that HCl as you pull it up into the micropipetter so that it contaminates it. All right, so that's 1 milliliter of hydrochloric acid. I'm just going to gently put the lid back on there so it doesn't tip over. And then I'm going to add this 1 milliliter of HCl to my unbuffered sucrose solution. Again, this doesn't have a buffer in it, so since this is a strong acid, it's probably going to make the pH go down even with 1 milliliter pretty dramatically. So I'll add it, and I'm pressing all the way down to the second stop in one smooth motion, and then discarding the tip because I don't need that anymore. All right, I'm going to give it about 10 seconds, so counting to about 10. And then I'm going to look at the display, and looking at the display, I have reached a pH of about 2.27. That is definitely below a value of 3. So that means I am done with this titration, because remember the value I was shooting for was 3 or below. All right, so that means I'm done with this titration. I can stop the stirring. I can take this pH meter, the electrode of the pH meter, out of the solution. And because I need to set up for the next titration, and it's going to take a little bit of time, I'm going to rinse the electrode off again as carefully as possible with distilled water. And then I'm going to set it back in this pH 7 buffer while I set up for the next titration. And all that really requires is for me to get rid of this solution, and you can tip this solution into a waste container that your instructor tells you to put the waste into. To avoid tipping out the stir bar along with it, you were probably provided a larger stir bar like this one. You'll hold it to the outside of your beaker so that the two stir bars, the one inside, the one outside, stick to each other. And that will keep the small stir bar in place as you tip it out into a waste beaker. And you may not see that very well, but that's okay. And then you're ready to move on to set up for your second titration. So the second titration will be with the other half of this unbuffered sucrose solution. But now instead of adding HCl to it, I'm going to add an equal molarity, 0.4 molar, of sodium hydroxide to it. And this is a base, which means that it's going to cause the pH of the solution to go up. And what we're aiming for with this titration is to do the same thing as we did with the HCl, add it to the solution 1 milliliter at a time, but we're aiming for a pH value of 11 or above. So I'm going to set up the titration of this half, same way I did the first half, put a stir bar in there, small stir bar. I'm going to get it stirring like I did before. Then I'm going to move the stir bar by moving the beaker to one side of the beaker, so it's not going to hit the electrode once I get it in there. Next, what I'm going to do is grab the electrode again of the pH meter and rinse it off again like I did before. And just like I did with the other half, before I titrated with the hydrochloric acid, I'm going to set this electrode in the beaker away from the stir bar so they don't hit each other, and I'm going to measure again the starting pH of this solution. And sometimes what happens is you get two slightly different starting pHs. That's okay, we're just going to use it as a baseline. All right, so stick it in there, make sure it's going to stay in there, count to about 10. Let's say we've reached about 10, and then we're going to measure that pH so it's about 8.56. So what I'm going to do next is what I did before, but now with sodium hydroxide and not hydrochloric acid. I'm going to put another tip onto this micropipetter, and I'm going to add 1 milliliter of this sodium hydroxide, measuring it first, so pressing down to the first stop, putting the tip in, drawing up the liquid in one smooth motion. And I'm going to add it carefully in one smooth motion, press all the way down to the second stop. Then I get rid of the tip, give it about 10 seconds or so. Let's say we've reached about 10 seconds, and I'm going to read the display, and we were aiming for a pH of 11, and it's above that, so 11.58, 11.59. So that means I'm done with this titration. So these titrations were so easy and required very little HCl or NaOH to get to the set points that I was aiming for, because again, there was no buffer present in the sucrose solution to begin with. The other two solutions have buffers in them, and therefore their titrations will take a little bit longer, because the point of the buffer is to resist that pH change that you saw happening to this unbuffered sucrose solution. Now that you've seen how dramatically an unbuffered sucrose solution will change in pH, even with the addition of 1 milliliter of a strong acid or a strong base, now I'm going to demonstrate to you how a buffered sucrose solution, and this happens to be the sucrose solution with acetic acid and sodium acetate, that's a weak acid and base combined together to form an acetate buffer, how the presence of the acetate buffer will make the solution more resistant to that dramatic drop or rise in pH. So it's going to take more additions of either HCl in this case or NaOH to cause the pH of this solution to change. Now, starting off, the pH of this solution should be, if you measured everything properly, 4.8. So hopefully when we get the electrode into this solution, it should say a value of about 4.8. So even though we know it should be 4.8, we're going to measure the starting pH of the solution anyway, just like we did for the unbuffered one. So yet again, I'm going to take the electrode of this solution, of this pH meter, and I've already put the stir bar into this beaker and sort of scooched it to one side. I'm going to rinse it off again very thoroughly with distilled water. And then after I've rinsed off thoroughly, I'm going to again gently place it in my beaker, pointing it away from the stir bar. So I'm going to move the stir bar a little bit to one side, and I'll put the electrode in there. I'm going to count to about 10 again. And then I'm going to look at my display, and congratulations me, I made the solution properly, because the value starting off with is about 4.8. So I'm going to record that 4.82, and that would be again with 0 milliliters of, in this case, hydrochloric acid or HCl added to this solution. Once I've noted that starting pH of this solution, now I'm going to add 1 milliliter time, like I did before, of hydrochloric acid to it. Wait 10 seconds after each addition, read the pH again, and again, like before, the aim is to get a pH value of 3 or below. When I do it again with the second half of this acetate buffered solution, I'm going to add sodium hydroxide, 1 milliliter time, aiming for a pH value of 11 or above. So let's add the HCl first to this half. And I'm going to add it in one motion, pressing down again to the second stop on this plunger, and then I'm going to get rid of the tip. I'm going to wait about 10 seconds like I did before I read the pH value. And if you take a look at the display, it hasn't really changed. It's still at about the starting pH, and that's the power of the acetate buffer, that acetic acid and sodium acetate combined together, that's in the solution. Even though I'm adding a strong acid to it, it's not dropping its pH, at least not right away. So I'm going to add another increment, another 1 milliliter measurement of this HCl, because I haven't reached a pH of 3 yet. I'm going to add it. Wait about 10 seconds. Then looking at the display, it's still about the same. It might have gone down a little bit, but not a whole lot, all right? So that means I have to do it again, and I'll do it a third time. And what you're really seeing right here, when the pH stays stable, is the flat portion, that very horizontal portion of a titration curve. So some solutions might have just one flat portion. That's sort of what we're creating right now for this solution. Sometimes there could be more than one flat portion, but we're definitely seeing that plateau, that sort of horizontal plateau of a titration curve right now. So at a third amount, 1 milliliter addition of HCl. Wait another 10 seconds again. And then look at my display again. And again, it stays pretty stable. So this will keep on happening, and you will keep on observing that this pH stays stable until eventually you will add another milliliter of HCl, and then all of a sudden it'll shoot down in pH to that value of 3 or below. And that's when you know to stop this first titration. And with the second half, you'll repeat it exactly the same way, but again by adding, instead of HCl, the sodium hydroxide. And when you do that, it's probably going to stay stable again, the pH will, because there's a buffer in this solution. And then all of a sudden, it'll probably shoot up to that value we're shooting for, which is 11 or above. And that's when you know to stop that particular titration.